Okay, now for part B. So in part B of that problem, remember it's asking you to find the distance traveled in the whole first 20 seconds, okay? So let's go back to the part that I worked from before. So here we go. This is where we left off. We had a velocity at t is equal to 10 seconds of 20 meters per second, and then because of that negative acceleration, slow down here because the velocity is in the positive direction, the acceleration is in the negative direction, they point oppositely. So that means that you have a slowing effect to 5 meters per second at 20 seconds. So now I can use this information to plot what's happening on my velocity versus time graph, which I've done here. So remember, we start from rest, so that means at t is equal to 0 seconds, we have 0 meters per second as our velocity or speed. And then we're going to increase, okay, our velocity from 0 to 20 meters per second. And that's what we found here. Now remember, this is going to be a straight line because in our plot over here, we had constant accelerations. Constant accelerations means straight lines on v versus t graphs. Then between 10 and 15 seconds, remember that we had 0 acceleration. That doesn't mean no motion, okay? It just means constant velocity. So here we have a constant velocity of 20 meters per second. Between 10 and 15. It's just going to stay at whatever it was at the time when it went to 0, okay? Then, between 15 and 20, we have negative acceleration. Okay, that means a negative slope on a v versus t graph. So that goes here. And remember, we found the final velocity as 5 meters per second at time t is equal to 20 seconds. So we have this negative slope, straight line because it's a constant acceleration, straight line slope, negative, ending at 5 here. Now what we need is that total displacement during that time interval. So here the red lines I've used to indicate, I'm going to break this up into little shapes that I can easily find the area of, and these little shapes guide me. So for my first 10 seconds, I have a triangle, okay, and I can easily find the area of a triangle. Then between 10 and 15, I've got a rectangle, that's easy, and then from 15 to 20, I have a little rectangle and a triangle here, rectangle here. Remember, I need to find the area under the curve, the total area under the curve. So between this line and this curve, I don't leave the rectangle out because that counts. It's between those two lines there. All right, so I need to find the distance traveled. I've got them both up. Okay, so for the first 10 seconds, I've got constant acceleration. Actually, I can make this go away now. And for the first 10 seconds, remember I have that triangle. So if I want the displacement on a v versus t graph, I take that area. So my displacement is equal to area on a v versus t graph. For the first 10 seconds, that's a triangle. Base times height divided by 2. So that's a base of 10 seconds, a height of 20 meters per second. 1/2 10 times 20 is 100 meters displacement for the first 10 seconds. Now between 10 and 15 seconds, I have a rectangle, this rectangle here. Okay? So my base is 5 seconds, 20 meters per second. Area of rectangle is base times height. So that's 5 times 20 for 100, and that's a 100 meter displacement during a 10 to 15 second time interval. Now remember that 15 to 20, it's a little trickier. Okay, I need that total area. So I have both a triangle and a rectangle during that time interval. So here's my rectangle, base times height, and then for my triangle, 1/2 base times height. So to find that, my rectangle is 5 seconds times 5 meters per second is the height of my rectangle. That gives me 25 meters for the little rectangle. And now for the triangle, looking here, the triangle has a height that goes from 5 to 20 meters per second. So that total height of my triangle is 15 meters per second. So that's what I've got plugged in here. 15 meters per second is the height of my triangle, times the base is 5, and then divide by 2. So that gives me 37.5 meters area for my triangle. Then I sum those two things up to get a total of 62.5 meters displacement between 15 and 20 seconds. Now if I want the total displacement between 0 and 20 seconds, then I have to sum all these up. 100 plus 100 plus 62.5 gives me a total displacement of 262.5 meters, and that's going to be my total distance traveled in that first 20 seconds. So that solves the whole problem for you, the whole case control. So hopefully that helps you understand how to go backwards and use the area under the curves on acceleration versus time and velocity versus time graphs to find your velocity and displacement.